Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Patel, and we are going to continue our chapter Cam and Follower. Okay, in this lecture we are going to solve another example of cam profile, but in this example we are going to solve a flat face type follower. Okay, start with this given data. Okay, so check this. A cam drives flat reciprocating follower. Okay, we already solved the knife edge type follower, but in this example we are going to solve flat face. Okay, all other data and for the displacement diagram, base circle, all will be same. Okay, there is no difference will be there, only change is a flat face. So there is a displacement diagram will be same, but there is only change in a cam profile. Okay, so during the first 120 degree cam, followers moves outward through distance 20 mm. It means that theta 1 rise angle is a 120 and lift or stroke is a 20 degree. Okay, with simple harmonic motion means our displacement diagram will be as per simple harmonic motion. Okay, for the rise. Okay, for the rise. And the follower dwell during the next 30 degree, theta 2 is a 30. During next 120, follower will move inward direction with simple harmonic motion. So inward and outward, both rise and return, both are simple. SHM method is applying for the displacement diagram. The follower dwell for next 90 degree and minimum radius of cam is a 25. So base radius or minimum radius is given 25. So draw the profile of the cam. So you can check the given data we have obtained. Okay, so first of all check this 20 degree 120 is a theta 1. After that you can see the distance is a rise or lift, simple harmonic motion, dwell for next 30 means theta 2 is a 30. During next 120 cam profile with simple harmonic motion, it is return. Okay, inward meaning of inward is a returning the follower. So 120 return angle, remaining 90 there is a dwell. So and minimum radius of cam is a 25, so it is a 25. So always remember that this 6 data is always be there: lift, 4 angle, rise, dwell, return, dwell, 4 angle. Maybe sometime there are less dwell is there, like a rise, return and dwell only. There is a no dwell between rise and return sometimes. Okay, and 6 and last data is a base radius. And as you know that simple harmonic motion for rise and return, flat face reciprocating follower. So in this case we have to make the flat face follower. And direction of cam is not given. Remember that if the direction is not given, we are assuming that it is rotating in a clockwise direction. So our profile will be in an anti-clockwise direction. Let's start. So this data is already there and we are going to make displacement diagram. I am not wasting any time in displacement diagram because we already know that. First make the rectangle whose make the rectangle length will be 18 and height will be 20 because lift is given. After that make the partition or of this rectangle depend on these angles 120 30 120 30. So it will be first to 6 centimeter. Okay, after that 1.5, then again 6 centimeter and remaining will be for 4.5. So this is the partition. Depend on this we have to divide 120 divided by 20 because our scale is a 20 degrees equal to 1 centimeter. Divide this angle by 20. 120 by 20 is equal to 6. So you know that this will be 6 centimeter, this will be 1.5, this will be 6 and this will be 4.5. So that's how you will divide this total 18 centimeter into 4 parts, theta 1 2 3 4. And after that you know that division, 6 part of rise and 6 part of return. And so this is your displacement diagram for simple harmonic motion. What you have to do here, first of all, make the 6 partition of rise and return, give the number 1 2 3 4 5 6, same as in return stroke, name will be 0 dash 1 up to 6 dash, and make this semicircle here and divide this semicircle into 6 parts. 6 parts means there will be total 120 degrees there. Using protractor you will divide this 30 degree portion, 30 30 30, all 6, and extend these lines up to end of the return. Extend this line up to, like these lines up to end of the return, and whenever this intersecting vertical line, which vertical line depend on this, like if you are going to this C means third line of vertical, means this point will be D, E, F, and make this graph. For displacement diagram, check my older video of for the simple harmonic. Okay, now we are going to start the cam profile, and how we will make this cam profile here. It is very similar to knife edge, very similar. Okay, but this is the flat face follower is there, so there is some changes are there. Okay, let's start. So first of all, check this. Base radius is at 25. So first of all, make circle of 25 mm, means 2.5 centimeter. In knife edge, what you are doing? Make the vertical line from the center. If the center is here, you are making the vertical line. Okay, and with respect to this line, you are making parts of this circle, like first angle is a 120, so 120, again next 30 theta 2, and again 1. So these are the theta 1 2 3 4. We have divided this circle in a 4 part, 1 2 3 and 4. Okay, all angles are ready. Now what you are going to do, partition of rise and return in a 6 part. So this is that 120 degree, this total angle is a 120, so 6 parts means 20 degree each. We are making 20 degree each, like first of all I am dividing into 60 60, and then 6 part of rise and 6 parts of return. After that, what you are going to do, give the numbering here. First of all, check this is a 0, because we have here 0 here. After that, 1 2 3 4 5 and 6. Okay, like this, 0 1 2 3 4 5 and 6. Okay, I am not doing for this return, same will be here. Okay, like partition and 0 dash to 6 dash. After that, what you are doing in a knife is similar will be here. Measure the distance from 1 to B and make the arc, means here will be B, give the only arc. 2 to C distance, you can check that this 2 to C distance here, so 2 and C point will be, you will get here, and that's how you will get all points here like this. And in knife edge, you are directly draw the profile, but in a flat face you have to make the flat face at each point. Okay, each point, like first of all take any dark color like this. We have to make the flat face at every point. And what will be this length of this flat face? This is the assumption. If not given in data, we can take 3 centimeter or 4 centimeter for any example. Okay, but how we can draw this 4 centimeter, 2 centimeter of each side? Like if I want to draw the flat face here, what I am going to do, 2 centimeter this side, and passing this point and perpendicular to the line, this 4 centimeter will be I will draw. Okay, and here if you can draw these points like this, so 2 points like this, okay, 2 centimeter this side, 2 centimeter this side, and like this. So remember that you have to draw flat face at every point, okay, every point length will be same, 4 centimeter, 2 centimeter each side, okay. Now what is the trick in this example? Whenever you draw the cam profile, okay, when you are going to start from this point and you are drawing the profile, it is not necessary to draw through the line, okay. We have to draw this line like tangentially touch the every flat face, like you have to very lightly draw this profile and it must touch the flat face at any point. It is not necessary to must touch at a center or here or here.